Lesson 4.8, Absolute Value Equations. Let's review absolute value. In Module 1, we discussed that absolute value is distance from 0. Therefore, it's always positive. Distance can never be negative. The absolute value of 7 is 7. And the absolute value of negative 7 is also 7. The absolute value of 32 is 32. And the absolute value of negative 2 is also 32, because these are the same distance away from 0. And we use this to solve equations with the absolute value of a variable. Okay, with the absolute value of a variable by itself, the absolute value of x is equal to 5, for example. Since the absolute value of 5 is 5 and the absolute value of negative 5 is 5, this means x could be either 5 or negative 5, but we don't know which one. So when we're solving this, the absolute value of x equals 5 means that x equals 5 or negative 5. We have to list both solutions. So if we solve equations with the absolute value, for example, x plus 7 equals 19, our first step is to isolate the absolute value of x, just like we would if it was x by itself. So first I subtract 7 from both sides, and I get the absolute value of x is equal to 12. Then I solve for both values of x. If the absolute value of x is 12, that means that x is 12 or negative 12. So here are some more examples. Okay, so first I have 3 times the absolute value of x, so I'm going to need to divide both sides by 3 to get that the absolute value of x is equal to 12. That would mean that x is equal to 12 or negative 12. Here I have multiplication and subtraction. So I'm going to add 10 to both sides, and I get 4 times the absolute value of x is equal to 32. Then I divide both sides by 4, just as if this was an x by itself. I get the absolute value of x is equal to 8, and that tells me that x is equal to 8 or negative 8. Okay, here I'm going to subtract 19 from both sides, and I'm going to get 3 times the absolute value of x is equal to negative 15. Divide by 3, and I get the absolute value of x is equal to negative 5. But absolute value cannot be negative, therefore there are no solutions. But you always want to see how I did divide by 3 first. We always want to do that because in this example, I might see this and say that's a negative 6 and jump to no solutions. However, when I divide both sides by negative 2, I have the absolute value of x is equal to 3. That's positive, so I get 3 or negative 3. You want to be really careful to get the absolute value by itself completely before you determine if there are no solutions. If we have more than a variable inside the absolute value bars, for example, the absolute value of x plus 3 is equal to 5. Again, because the absolute value of 5 is equal to 5 and the absolute value of negative 5 is equal to 5, that means that x plus 3 can be either 5 or negative 5 and give us a correct answer. Whatever is inside the absolute value bars will equal 5 or negative 5. So in order to solve for x, we have to take x plus 3 and we have to set it equal to both 5 and negative 5. We have to split the equation. So the absolute value of x plus 3 equals 5. Step 1, isolate the absolute value if necessary. So if there was anything else on the outside of the absolute value, I would take care of that first. Step 2, we split the equation and we set this equal to both positive and negative values. So I have x plus 3 equals 5, and I have x plus 3 is equal to negative 5. Then I solve for x in each equation. And I get two different answers. So x is equal to 2 or -8. When dealing with absolute value, you will always have two answers. So here we go with some more examples. I have the absolute value of 2x plus 3 minus 7 equals 14. I need to get that absolute value alone, so I add 7 to both sides, which gives me the absolute value of 2x plus 3 equals, not 14, 23, 21. I cannot add today. 21. Now I split, so I have 2x plus 3 equals 21, and 2x plus 3 equals -21. Now you'll notice I'm not changing the sign or anything that was inside the absolute value. That part stays exactly the same. All I change is 21 into a -21, so I have both positive and negative. Subtract 3 from both sides, 2x equals 18. Divide by 2, x equals 9. Subtract 3 from both sides, 2x equals -24. Divide by 2, and x equals -12. So I have x equals 9 or -12 as my solution, or my solutions. Here I'm multiplying times the absolute value, so first I divide both sides by 3 to get the absolute value of 4x minus 5 is equal to 4. Then I split. Set that to positive and -4. Add 5 to both sides, 4x equals 9. Divide by 4, x equals 9/4. Add 5 to both sides, 4x equals 1. Divide by 4, x equals 1/4. You can leave this like that and put the word or in between. We always want to use the word or because it's one or the other. Here I have even more happening, so I'm going to subtract 10 from both sides. Then divide by 2, and I'll end up with the absolute value of x minus 6 equals 11. Split it. X minus 6 equals 11, and x minus 6 equals -11. Add 6 to both sides. I get x equals 17. X equals -5. Put the word or in between there, and you have your solutions. Okay, now this is another example where I have a negative, but I don't have the absolute value isolated yet, so I need to make sure it stays negative. But as you see, when I divide by -5, I'm going to get a positive 3. Split, and I get 3x plus 6 equals 3. 3x plus 6 equals -3. Subtract 6. 3x equals -3. 3x equals -9. And dividing by 3, I'd get -1 and -3.